Right, so we're going to extend today the work we were doing on Monday about percentage increase or decrease, and we're looking at grade B percentage work now, the title is Count Compound Percentages, and it's what you use when you are applying a repeated percentage change. It could be an increase, it could be a decrease, or it could be a combination of both to an amount. Okay, and what you need to remember, I've put in red there, so the percentage multiplier, well, we're used to using those now, is raised to the power of the time period. Now that sounds a bit of a mouthful, but it's quite straightforward. And what I'll do with the first example is I'll show you how we arrive at that. So we've got a bank that pays 1.8% PA, that means per annum, which is per year. Okay, so PA per annum, which means each year. So each year that somebody's got money in a bank account, in order to say thank you, what the bank does is it pays into that bank account a certain amount of money, and in this bank it works out 1.8% of what's in the account and chucks that into the account. How much will it be worth in 8 years? So interest payments are an increase. Okay, so it's an increase of 1.8%. So the multiplier that we're going to be using will be the 100% which was put in the account plus 1.8%, which is 101.8%. We need to turn that into a decimal. So if it was 101, that would be 101 pence written in pounds would be 1.01. So that's going to be 1.018. So that's our multiplier. So one way we could do this is by saying, right, well, I'm going to increase that £10,000 by 101.8%. So I'm going to do 1.08 times 10,000, and I can work that out. So 1.08 times 10,000, and that equals £108,000. Now at the end, £10,800. At the end of that year, there's no longer £10,000 in that bank account because of that. Hang on, I've done that wrong, haven't I? That's an 8% increase. I'm sure you're all screaming at the video then. It's 1.018 times £10,000. 1.018 times £10,000 is better. 1018. So basically the bank have paid this person £180 for keeping their money with them for a year. So that means now when it comes to the second year, the percentage, the 1.8% now, isn't based on the £10,000 that was there originally, because there's more money in the bank now. So what happens in the second year is that we're going to work out 1.018 times that, and that will give me an answer. And then in the next year we'll be doing that times whatever that answer was. So what that means, we keep doing that for 8 years. So basically we're starting off with the £10,000. In the first year that earns £180 of interest. At the end of the second year, as long as no money's been taken out, then the 1.8% is increased on that value rather than the original value. So there'll be a bit more, it'll earn more. Let's have a look. So if we do that times 1.018, you can see in the second year it's going to earn £363.23 in the bank account. So that would be and so on 8 times. Now, what that is the same as doing, so what we're doing is the same as the original value, which is £10,000, multiplied by 1.018 8 times, one for every year. So it's the original amount times 1.018 times 1.018. I'm not going to write them all out, 8 times. And in maths, we've got a way of writing that so we don't have to write it 8 times out. So if we're multiplying something by itself, what we're doing is raising it to the power of 8. So in order to answer this question, you don't have to do this repetitive building. You don't even have to write it out like that. You just need to write it as the original amount, which is £10,000, times the multiplier raised to the power of the number of years. So the way we're going to write that on our calculator now is 10,000 times, and you don't need to use brackets here. I put it in brackets because it's easier to see. So if I do it both ways, just to show you, 1.018 close bracket, and then the power button is, you've got the x squared button which just squares it, but next to it you've got x to a little white block. If you press that, it means that you can put in whatever power you like. We're going to put the power of 8 in there. So the answer is 1153, and because we're working in money, we're going to round to the nearest penny unless they tell you otherwise. So that's 2 decimal places, should be 40. Look at the next digit along, it's bigger than 5, so that would round to 41. Sometimes they tell you to give it to the nearest pound or the nearest whole number. So that's with brackets. If we're not going to use brackets, just to show you it's the same thing, £10,000 times 1.018 to the power of 8, which equals, hang on, what have I done wrong there now? I think I did £1,000, not £10,000 first time. So I think that should be, I'll go back and check now. Oh, it's the same thing, isn't it? It's 11,000. We got £11,534 and 6 pence. So hopefully you were shouting at the video again then. Jones, you are not having a good morning. So let me do it. £10,000, 4 zeros, times open bracket 1.018 close bracket to the power of 8, and that should now give me the same thing. Yeah, £11,534. So this is the only bit you need. Okay, all the rest of it was blurb, me trying to explain what's happening here. Okay, the most common mistake people make with this type of question is they'll work out what 1.8% is, which is £180, and then multiply that by 8 to work out the amount of interest. Now that's a different type of interest, that's called simple interest, and that's a sort of grade D type question. Okay, that doesn't work because every year you're working out your multiplier of an increasing amount. When you're working on the slides, if you're going to type on your slides for me, then to show the power on your slides, type this . So you would do 10,000 times 1.018, and then use the little up arrow symbol, 8. That's the mathematical symbol for to the power of, if you haven't got a clever little screen like our calculators have. So if I see that up arrow, I know that you're doing the right thing. Now, it also works with a decrease, so it's the same sort of thing again. So a new car loses 19% of its value during the first year and 5% of its value thereafter. So this is loss. Sometimes it's called depreciation. So it might say here a new car loses its value, or it might say it depreciates by 19%. It means the same thing. So when I'm working out my multiplier this time, my first multiplier number 1 is going to be the 100% less than 19%. So that's going to be 81%. And 81% as a decimal, 81 pence written in pounds. So in the first year, it's going to lose, it's going to end up as 81% of its original value. And what happens with cars is they lose a lot of money in that first year, but after that they don't lose as much year on year. So the second multiplier that we're going to use here is a 5% loss. So that's going to be a 95% multiplier, which is 0.95. So we've got a loss rather than an increase. Earning interest in the first example, so the multiplier was being added. In this example, we've got more than one percentage to work with, but they're both losses because the car's losing money. So if we want to work out the value of the car after 10 years, it's going to start off at 30,000, and then the first value, the first bit of depreciation is the 0.81, and that's going to happen once. That depreciation's only going to occur in the first year. And then after that, we're going to have the 95% multiplier, and that's going to happen every other year for 10 years. So I've already got through the first year, so I've got another 9 years of loss of depreciation at that percentage. So to calculate the value of the car after 10 years, we can just type that into our calculator. So 30, make sure we get the right number of zeros this time, 30,000 times, I'm going to use the brackets just because it's easier to separate out what you're doing. So I've got 0.81 to the power of 1 times 0.95 to the power of 9. So after 10 years, this car that cost £30,000 when new is going to be worth 15315, and it's unlikely, I mean we can add in the 6 pence as well, but usually when you're buying a car you wouldn't hand over the pence, so rounding that one to the nearest pound would have been fine. Okay, if that question had said how much money has been lost over the 10 years, then slightly different question. What you would then have to do is work out, well, you know it cost 30,000 when new, it's now worth that much, so how much is it lost would be the difference between the two. Okay, every so often these come up on a non-calculator paper, And when that happens, of course, we're not going to be using raising to the power. So when that happens, it's a slightly different method. So Jenny invests £400 for 2 years at 5% compound interest, paid annually. Tim says the interest Jenny will receive will be £40. Is Tim right? So first of all then, we need to work out what 5% of 400 is. So 10%, remember this is non-calculator now, so we divide by 10 is £40. So 5% will be half of that, £20. So at the end of the first year, Jenny will have the amount that she had at the start, £400, plus the 5% interest. So she'll have £420. Now we're going to do this over 2 years. Okay, for 2 years. So we repeat the process now. We want to now work out what 5% of that is. So 10% of 420 now will be 42. So 5% will be £21. So at the end of the second year, Jenny has 420 plus 21 is £441. So is Tim right? No. Tim is wrong. Tim said she'd receive £40 because they doubled the 20, but because they're working out the 5% of a different larger value, it'll actually go up. So she won't receive £40, she's actually received £41. So those are more uncommon these days on exam papers. So we've looked at a compound increase, we've looked at a compound decrease with a change in interest. We've looked at a non-calculator method, which will only be 2 or at most 3 years. And then the last one, which again is quite rare, but we better cover one in case, is you could be asked to find a time period. So what I've got here, a motorcycle depreciates by 16% per annum per year. It's a depreciate, so the multiplier is going to be a subtraction. After how many whole years will a motorcycle which was bought new for £2,500 be worth less than £1,000? So this is going to be a kind of trial and improvement. So the multiplier will be 100%, the original amount, less 16%, which is 84%, and as a decimal, 84 pence, written in pounds, 0.84. So the maths that we're going to do is going to be 2,500 times 0.84 to the power of. And what we want to do is to increase the power, so this is the first year, then we're going to do it the second year, until the value that's left is less than £1,000. So 2,500 times 0.84 to the power of 1. So we've got 2,100 in the first year. Second year, so we just go up to our power and change it to 2. we're at 1764. Go up, change it to a 3, we're at £1,481.76. We could jump if we wanted to. We could try 6. So that's already gone past. So I'll go 5. So 5. So after 5 years, it's over £1,000. Still bigger than £1,000. After 6 years, it's dropped below. So going back to the question, after how many whole years will a motorcycle which was bought new be worth less than £1,000? So it's after 6 years. So these questions come up every year on a numeracy paper, still pop up every so often on a maths paper where they're asking you for a multiplier, and what I've covered in those 4 examples take you through all the types that you could come across. So you could come across increase, where it's earning money or raising in value; decrease, where it's losing money; a non-calculator method, a question where you've got more than one type of increase or decrease, and one where you're trying to work out the number of years. The key thing to remember is that interest increases the multiplier, so it's 100% plus. Depreciation or loss decreases the multiplier. Okay, so hopefully you've got your head around those. So what I want you to do now is to go onto the slides and have a go at the questions that I've left you there. Remember, if you're typing in for me to mark, the power of is the little up arrow, which on my keyboard is Shift 6. Okay? Good luck. If I'm stuck, you know where to find me.